Let's talk about this question next. Let Z1 equals 2 minus I, Z2 is equal to minus 2 plus I, and we are supposed to find the two parts of this question. In the first part, we are supposed to find the real part of some expression depending on Z1 and Z2. And in the second part, we are supposed to find the imaginary part of some expression depending upon Z1 and Z1. Z1 and Z1 bar is there. Okay. How to go about attempting this question? It is pretty simple. First of all, instead of finding the real part directly, what we'll do is we'll first simplify this expression over here. Let's take a look at this expression and try and solve the first part. So first thing that we are supposed to do is simplifying this expression. Let's take a look at the expression first. What do we have in the first part? We have Z1, we have Z2 and the conjugate of Z1, that is Z1 bar in the denominator. Okay. Let's write Z1. Z1 is 2 minus I, Z2 is minus 2 plus I, and the conjugate of Z1 would be Z1 bar, which is actually 2 plus I. This is 2 plus I over here, right? Let's simplify this. Okay. Well, multiply these two terms in the numerator. What you get is 2 times 2. Okay. Or as you can clearly observe, okay, let's multiply them together. You can also observe that this is negative of this actually, right? You take a minus common and what you get is a 2 minus I. This is already a 2 minus I. So this is actually 2 minus I times 2 minus I. I can move in that direction, or I can directly multiply by using the distributive law. That is 2 times minus 2 would be minus 4. 2 times I would be 2I. Minus I and minus 2 multiplied together would give me plus 2I. And minus I plus I would be minus I square in the numerator. The denominator is 2 plus I, which is not difficult to handle. We'll multiply with 2 minus I over here and 2 minus I over here. The complex conjugate of this 2 plus I in the LHS, on the right hand side as it is, right? That's what we have, okay? So on getting this expression, what do we get is, let's take a look at this. This is minus 4 and this becomes minus of minus 1, which is plus 1. So minus 4 plus 1 would be minus 3 plus 4I in the numerator, the first term. The second term would be 2 minus I, as you can observe over there. In the denominator, you get a plus b, a minus b, which will be a square minus b square. That is 2 square, 4 minus I square. That's what you will be getting, right? Okay, let's simplify this further. By multiplying the numerator, what you get is minus 6. This minus 3 times 2 is minus 6. Minus 3 times minus I is plus 3I. 4I times 2 is 8I. And 4I times minus I is minus 4I square in the numerator. In the denominator, you get a I square is simply minus 1. So this becomes 4 plus 1 over here. Okay, what next? Let's continue further and simplify it more. This further becomes equal to, this is minus 4I square, which becomes minus 4 into minus 1. That's plus 4 minus 6. Okay, plus 4 minus 6 would be actually minus 2. This is 8 plus 3, which is 11I, whole divided by, you have a 5. And this gives me minus 2 by 5 plus 11 by 5I. This is the expression that Z1, Z2 over Z1 bar. That expression is equal to this. Therefore, real part of Z1, Z2 over Z1 bar is actually equal to what? Real part of this whole thing, as you can observe, that is simply minus 2 by 5. And yes, that is my answer for this question over here. This is first part for us of this question. Let's try and take a look at the second part. Now, second part once again is not very difficult to handle. What you have over here is Z1, Z1 bar in the denominator. Now, one of the ideas is to simplify Z1, write Z1 bar and then multiply them together. Or another approach would be, what you need in the second part is 1 over Z1 bar. Now what is that equal to? ZZ bar, as you may recall, ZZ bar is actually equal to mod Z square. What we know is Z bar is equal to mod Z square. This is something which we know. So this is mod Z1 square in the denominator, right? That's what we have. And modulus of something is actually only a real number. That's what we know, right? So what do we get over here is something very simple. What you get over here is actually Z. For Z1, this is 4 plus 1, which is 1 over 5. This is this whole thing. And what's the imaginary part in this case? I can write it as 0i. Therefore, imaginary part of 1 upon Z1, Z1 bar is simply equal to 0. That's what I can observe over here very easily. And yes, this is the final answer for this question over here.